so lesson time. All right, so for both of these scenarios, you're going to have another option today, okay? One of them is just really tricky, so you might want to use the option. The other one is only possible with the other option. All right, so what would we do here? Well, we've set it equal to 0, 2x squared minus 9x minus 56. We notice it's in standard form. We know it doesn't have a GCF because 9 doesn't divide by 2. So we're thinking either rainbow or reverse box here, right? Those are our two options. So I'm gonna do rainbow, which tells me I should do A times C, which is 2 times negative 56, which is negative 112. Okay? So negative 112, there are two numbers that multiply to give you that, and those same two numbers should add to give us negative 9. Now, I was going to say, this is possible. We're about to find out. But you might stare at this for 10 minutes and be like, I can't figure this out. And that's okay, because we're going to give you another option today, right? The option we have is if things get too tricky here. But if you can figure it out, it is what? Negative 16 and 7 works for both situations. Remember, for the rainbow method, we rewrite this as 2x squared, and instead of negative 9x, we write negative 16x plus 7x minus 56. Right? We just pull apart that b into two numbers. Now, I look for GCFs in each situation. So I say, okay, in this first situation, the GCF is 2x. So 0 equals 2x. 0 equals 2x, and then divide them both by 2x, I get x minus 8. In this situation, the GCF is just 7. So I say plus 7, x minus 8. Okay? Now, this is the kind of confusing part, but a GCF is something that you can pull out of two terms, right? It's something that you can divide them both by. I can divide this and this by what? X minus 8. So that becomes my new GCF, x minus 8. And then I am left with 2x plus 7, right? If that's tricky, right, just say this goes out front, the other two go in the back. Now I can solve this because I got zero product property. So this becomes x minus 8 equals 0. And 2x plus 7 equals 0. Add 8, add it to both sides. I get x equals 8. On this one, minus 7, 2x equals minus 7. Divide by 2, divide by 2. And I get x equals negative 7 halves. Okay? So that's what would you do? A little review of rainbow method, but maybe you could never figure this out, and that's why we have today's lesson. Now, this other problem that we're going to do over here, again, you're going to attack it the same way. You're going to say, hey, there's no GCF. I don't have an A of 1. I can't magic X. I'm going to try rainbow. I'm going to try see if it works, right? And then you go to do it. You do A times C equals negative 50. So, okay, negative 50 equals something times something. And those same two numbers have to add up to negative 4. And you sit there and you think about it and you're like, I can't find any numbers that fit that scenario, right? In this case, that's because there aren't any, okay? There are times where it doesn't work. Think about the numbers 8 and 7 halves. They're kind of clean numbers, right? Every x-intercept is not going to be a perfectly clean number. Some of them are crazy decimals, right? In order for one of these methods to work, you have to have clean numbers, and that's not always going to be the case. So when you have some crazier numbers, there's another formula that we need to use, okay? Now, I put put up two scenarios on purpose. One where you have to use it, one where maybe you just want to, right? Because if you're sitting there trying to do the rainbow method and you just can't come up with the numbers and you can't figure out, is it because I can't get the numbers or because they don't exist? It doesn't matter. Either of those scenarios, whether you can't figure them out and they're there but you just can't figure them out, or they don't exist. Who cares which one it is? Move on. Do this other thing, right? It doesn't really matter which of those scenarios you're in because this other thing will work. Now that other thing is the quadratic formula. Yeah. So that is our break in case of emergency, works for any standard form quadratic. And when I say any standard form, I mean literally any. X squared plus 4x plus 4, like super easy, but you just factor it real quick, get your answers. But if you really wanted to, that would work for it, right? It works for any standard form equation. Now, it's complicated and it's tricky, but if you get good at it, then you only have to have the one strategy and you can just use it every single time, right? You can throw some of the other ones out. The reason we teach the other ones is they're a little easier to do than that. But some students just, once they figure that out, they're like, sweet, I'm going to use that. Like, that's what I'm going to use. Some students are like, I'm only using that when I have to. It doesn't matter. You can be either one, and that's okay. All right, so what do we need to do? Well, first, let's write down the formula. The formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so yeah, it's a lot, right? And that all over part's important. You got to divide the whole top by 2 times a. But it's both a lot and not, because all you need to do is take your a, b, and c and plug them into this. Like, you don't have to be, there's not like a ton of steps here. It's just plug them in and evaluate, right? So my a, in this case, was 10. My b is negative 4. And my c is negative 5, right? I just plug those in. Be careful when you plug them in. Use the right parentheses where you need to, but just plug them in, okay? So let's see what we got here. We get x equals negative. Our b is negative 4, so that's negative, negative 4. So put parentheses around your negative 4. Plus or minus, open up a big square root. B squared, that's negative 4 squared. Minus 4 times a, which is 10, times c, which is negative 5. All over 2 times 10. Now, this looks like, whoa, what am I going to do with this? You're going to do it in 3 little pieces here. This is what you're going to do. You're going to say, okay, let me bring down my x equals. You're going to evaluate this little first part, the bottom part, and then worry about what's under the radical. So what's negative negative 4? 4. Plus or minus, open up a big radical, and then we'll come back to it. We'll come back to it. Divided by, what's 2 times 10? 20. All right, now what you're going to do is you're going to pick up your calculator, and you're going to put this, not with a square root, just like what are these numbers? What number do we have under here? Exactly as you see it. You're going to go parentheses, negative 4, parentheses, squared, and you're including your parentheses. And then minus 4, parentheses, 10, parentheses, negative 5, enter. Figure out what that number is under there. And then you write it in. So what is that number? What's that? Put this into your calculator. All right, it's 216. So first thing you want to do is check, is that a perfect square? Let's try to square root 216. Maybe it is. I don't know.
How do you know?
It's not. But you check, because sometimes it is. Okay? And then what do you think you have to do to that 216? Well, we tried to square root it. It's a decimal. So we're going to, we have to reduce it. So we go to 216, and we see if any perfect squares go into it. Just start dividing by 4, 9, whatever you think.
2 and
Well, 2 is not a perfect square. We want to get a perfect squares into it. 4. Okay, 216 divided by 4 is?
54.
54. Any perfect squares in 54?
9.
Yep. 9, and 9 times what is 54? 6. So 6 we can't break down, but we found 2 perfect squares. So square root of 216 is actually square root of 4 times square root of 9 times square root of 6. That's plus or minus 2 times plus or minus 3 times square root of 6, or plus or minus 6 square root of 6. So I'm going to take what I just found and put it in the place of 216. So I get x equals 4 plus or minus 6 square root of 6 divided by 20. Now there's one more thing you can do, and then you have your answer. It's it. You can say, well, let me ask you this. What would you rewrite 26 as?
1/3.
Why?
Divide by 2.
Because you can divide the top by 2 and the bottom by 2. Well, now look at this fraction. What can you divide every number that you see by? 2. Now, don't divide the radical, the numbers. So I'm going to divide everything by 2 if I can reduce by 2. X equals 2 plus or minus 3 square root of 6 over 10, and that's my answer. Now, what does that mean? It means I have 2 real solutions, and that's what they are. 2 plus 3 square root of 6 divided by 10, and then 2 minus 3 square root of 6 divided by 10. If you put those into a calculator and you pressed enter, you'd get a crazy decimal value. But then if you graphed this equation on Desmos and you looked at your x-intercepts, it would be that crazy decimal value. These are x-intercepts. But they're crazy, and that's why I took a crazy formula to find them. Okay? All right, I know we only have 5 minutes, but I want to show you that this will work even if rainbow method would have worked. So we're going to do the other one to show you that it can work with anything. Okay? So we're going to do the problem we already did, but with this formula. Remember, our answers were 8 and negative 7/2. If this thing should work for everything, we should get those same answers using this formula. This is the last thing we'll do. 2x squared minus 9x minus 56. All right. Y equals 2x squared minus 9x minus 56. Our formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. All right, my a is 2, my b is negative 9, my c is negative 56. Plug in each, right? So x equals negative 9 plus or minus negative 9 squared minus 4 times 2 times negative 56 over 2 times 2. Okay? All right, negative 9 is 9, so x equals 9 plus or minus whatever that number is over 4. Now I do that number in my calculator. Negative, parentheses negative 9 squared, minus 4, parentheses 2, parentheses negative 56. I press enter, and I get, anybody?
529.
529. And the first thing I check for is, well, maybe I could square root 529. That would make things a lot easier. So I try to square root it, and what do I get?
23.
Yep, you can do it. So that means this says x equals 9 plus or minus 23 divided by 4. Now, I thought our answers were 8 and negative 7/2. What can we do to get those?
Make it 2 equations.
Yeah, this is telling me 2 things, right? This is telling me x equals 9 plus 23 divided by 4, and x equals 9 minus 23 divided by 4. What is 9 plus 23?
9 plus 23.
32 divided by 4. What's 32 divided by 4? 8. There's our answer. And what is 9 minus 23? Negative 14 over 4. Can that be reduced?
It's going to be
Yeah. Divide both of them by 2 and you get -7/2, which was the 2 answers that we got when we did this with rainbow method. So I just wanted to prove to you that this will work for any standard form if you want to use it, right? If you'd rather use it. Okay. Sorry we had to rush there. A lot of homework problems. All right, let me give you your homework. So for the homework, this is one of the first times that you were given a bunch of equations, and it wasn't just like, oh, these are all solved by square rooting. These are all GCF. These are all magic X. It was just a mixed bag of equations, and you had to start identifying the situations, right, of which one is which and what strategy to use, right? So that was part of the design of the homework, and then also this is something that the graphic organizer will help you with, right? So identifying which of the situations do we have, what's my strategy for that situation, right? So you have to ask yourself that question every time, because on a test, you're not going to be able to just be like, oh, these are all the BX, missing BX problems. These are all the standard form problems, right? You got to be able to tell which one is which. All right, so with that being said, we can kind of just jump around. We don't need to go section by section here. So what I'll do is I'll ask if there are any questions on the front, circle those, back, circle those, and then we'll do them. Okay? So are there any questions on anything on the front side? Yeah. 1? 3? 5, 6, this has happened in every class. 5, 6, 2. Okay.
Just do 4.
What's that?
Should we just do 4?
Should we just do 4? We'll see. Okay, we'll see how it goes. I feel like maybe some of these problems will clear up other problems. We might not have to do them all, but maybe we will. All right, let's go to the back. What problems on the back? 9.
7.
11. 7. 10. That's it? That's all? Oh my. Oh my. This graphic organizer is not going to make it, is it? Okay. So here's what we'll do. We'll start knocking them out. And then if I see a problem where it's like, actually that was kind of just like that other problem, I will direct you back to that problem and we'll keep going, right? We'll do our best. All right. Let's start at the top. Number 1. All right. What's that? We'll get there. All right. So here's the thing. Before we use any of our strategies, there is a first step for all of these, which is what? Set y equals 0, right? That's one thing you can count on. I'm going to do that every time if I so choose. Well, you have to a lot of time, but yeah. Anyway, sometimes you get a choice. But okay, now I've set y equal to 0. Now I start analyzing the problem. Like, what type of problem is it, right? Is it vertex form? Is it standard form with all of its pieces? Is it standard form but it's missing its bx term, right? So which situation do we have here? This is missing the bx term. So when you recognize that, that should be like, okay, when I'm missing bx, I'm square rooting. I'm solving by square rooting. So now I'm going to try to get the square by itself. I'm going to isolate the square. So I've identified it. Now I'm moving everything to get that by itself, right? So I would add 150, add 150. I get 150 equals 3x squared. Now, I have not yet isolated the square. I need to keep going by dividing by 3, right? Because it's multiplying by 3, so we divide by 3. Always do the opposite. And I get 50 equals x squared. Okay? Once the square is isolated, it's by itself, you're ready to square root. Even if there's not a perfect square on the other side, right? Even if there's a negative on the other side, you got a square root. So I get x on one side, and then on the other side, I get plus or minus the square root of 50. Now, I just always add the plus or minus once I square root, because I'm going to need it eventually. I might as well just start putting it on there. Now, one thing I do a lot here, which I haven't really spoken to, but I feel like I should. Notice 50 was on the left, x squared was over here, and then I put x on the left and square root of 50. That's fine, right? I just like having x on the left. That's what I like. So when I get to that point, I just flip them. Like if that's what you want to do, that's fine. If you want to leave it on the right, you can leave it on the right. All right, so now I have square root of 50, right? Is 50 a perfect square? No, it's not in any of those red boxes over there, right? So I can't square root it, but maybe I can find a square root inside of it. So I ask myself, okay, 50. Well, I know my perfect squares are 4, 9, 16, 25, 36. Do any of those go into 50?
Yeah.
What? 25 does, right? So I'm going to say 25 and 2 instead of 50. So I say, okay, this will just be plus or minus square root of 25 times the square root of 2, right? I just pulled it apart, 25 times 2. Now, the reason I did that is I can do this part. Square root of 25 is what? 5, right? 5 times 5 is 25. So I get x equals plus or minus 5 square root of 2, right? And that is a more simplified answer than square root of 50. And that's my answer. How many solutions do I have? 2, because it's plus or minus, right? And are they real or imaginary? Real, because there's no negative under the square root. So how many x-intercepts should I expect to see? If I have 2 real roots. 2, right? Exactly. Yep. Okay. All right, number 2. All right, so set it equal to 0. There we go. Negative x plus 6 squared minus 6. Okay, so I asked myself all the questions. Standard form without bx, vertex form, what do we have? Vertex form, right? So vertex form, then my brain goes, what do we do in vertex form? We square root, right? That's how we solve, right? So that's another isolating the square. In this case, this is the square, right? It's not x squared, it's x plus 6 squared, but it's still the square. So I'm going to get it by itself. So I need to add 6, add 6. I get 6 equals negative x plus 6 squared. Now, it kind of looks like it's by itself, but it's not. There's something extra there that we still don't want. What is it? The negative, right? And a negative is kind of weird, but what do we know is really there? Negative 1. And when you put the negative 1 there, it makes it super clear that there's multiplication happening here. And when we have multiplication, we want to get rid of it, we divide. So that just makes it really clear to me that I got to divide by negative 1. So this becomes negative 6 equals x plus 6 squared. Okay, now I've isolated that square. So now I can square root both sides, right? Now I know I can square root here and square root here. What ends up happening is I get this plus or minus the square root of negative 6 equals x plus 6. Okay, so the square root of negative 6, right? Not a perfect square, and in fact, no perfect squares go into it. But I still need to simplify it because I don't square root negatives. That's not something we do in the real world. So our solution that we came up with is we pull that apart, kind of like the last problem. We say, well, instead of square root of 6, I'll have square root of negative 1 times the square root of 6. And at least that pulls out the negative part, because square root of negative 1 we know is what? There's a letter we use for it, I. So this becomes, and I've left off the plus and minus, but I square root of 6, right? That's better than square root of negative 6, because we got the I out of it, right? Okay, so then it gives me plus or minus I square root of 6 equals x plus 6. Pretty close, but I'm trying to get x by itself, and it's not by itself. It's with a 6. So how do I move that 6? Minus 6, right? I don't want x plus 6. I want x. So I'm going to minus 6 on both sides. I get negative 6 plus or minus I square root of 6 equals x. And if you want, you can flip that around, put x on the left. It's fine, though, if you want to keep it that way. All right, how many solutions did I have here? plus or minus means 2. Remember, what this is saying is x equals negative 6 plus I square root of 6, or x equals negative 6 minus I square root of 6. It's two different solutions, right? And what type of solutions are they? Imaginary, right? They have the I for imaginary, right? So that is, how many x-intercepts do we have? None, right? Because I got imaginary solutions. Okay. All right, so that one, that was different. That was good. All right, the next one was 3. Let's knock this out. Ready? Wait till you see how easy this one is. 0 equals, and when I say easy, I don't mean that not getting it is wrong. Sometimes we just don't recognize that, right? So, yeah, so 0 equals 2 times x plus 6 squared. You could just look at it and be like, what's the only thing that would make that 0? Negative 6. But that's okay, we want to practice. How do I get x the square by itself here? I can't square root, it's not isolated. I have to divide by 2. What's 0 divided by 2? 0. 0 equals x plus 6 squared. Again, the only thing that would make that true is negative 6. But let's keep going. Square root. I get 0 equals x plus 6, right? Minus 6, and I get x equals negative 6. And how many solutions do I have? 1. There's no plus or minus this time. And how many x-intercepts do I have? 1, right? This would have looked like this on a graph. It would have been to the left 6, and then been stretched. And we just touch the x-axis. Question?
How do we know when to put the plus on the plus?
Well, it's whenever you square root. The only reason I didn't do it here is, what's plus or minus 0? 0, right? So it didn't matter in this case. Okay. Next up was number 5. Okay. Again, we got to recognize our situation. Is this standard form? Is it standard form missing its bx? Is it vertex form? Does it need a GCF? Which one is it? Standard form, is the a value 1? Yeah, so I don't need to worry about GCF. I go straight to magic x. And I say, okay, minus 57, 16. Two numbers that multiply to give you minus 57, add to give you 16. This is a kind of a hard one, right? Because you're like, okay, wait a minute. I don't really divide into 57 very often. So maybe you just pick up your calculator, you start dividing by numbers, like 1, 2, well, 1 wouldn't help, but 2, 3, whatever. And then maybe you stumble upon it. The other thing you could do is what we're going to learn today, which is another option when magic x or rainbow method or reverse box just isn't working for you. Rainbow is A times C. When those are not working for you, there will be another option after today. Okay, it's a complicated one, but you will have another option. Does anybody know what these numbers are? It is 19 and negative 3. So those two numbers multiply to give you the top, add to give you the bottom. Again, that was kind of hard to figure out.
Yeah, I did get that.
It might have took you a little bit, and after today, you'll have another option if you couldn't figure it out. Okay, x equals negative 19, x equals 3. Two real solutions, two x-intercepts. Okay? All right, number 6. Man, these are all different. I can't really skip them. All right, 0 equals 1/2 x plus 6 squared plus 2. What type of situation? Vertex, so I'm going to try to square root, isolate the square, right? So minus 2, I get minus 2 equals 1/2 times x plus 6 squared. Now, I still haven't isolated it. It's being multiplied by 1/2. I have a couple options here. What do I need to do to get rid of the 1/2?
Multiply by 2?
Yeah, if I multiply by 2, 2 and 1/2 cancel each other. My other option is just think about it as multiplication and divide by 1/2. But that's a little trickier to do than just multiplying by 2. Because if I just multiply this by 2 and I multiply this by 2, it's pretty clean. I get -4 equals x plus 6 squared. Right? Now, square root both sides. And go over here. I get, square root of -4 equals x plus 6. Square root of -4, I know is really square root of 4 times square root of -1. What's that? So that's square root of 4 times square root of -1. So this becomes I, but what does square root of 4 become? Plus or minus 2. So this becomes plus or minus 2. This becomes I, and then I just bring this down, equals x plus 6. Right? So square root of -4 becomes plus or minus 2i. You don't have to just know that. You can just pull it apart, evaluate this, and that's what you'll get. Okay? Now, I want x by itself, so I minus 6. I get -6 plus or minus 2i equals x. Two imaginary solutions, no x-intercepts. Okay? Questions? Yeah.
How would you put, like when we multiply by 2, how would you put that in the calculator?
Over here?
Yeah.
I wouldn't really do it in a calc. If you wanted to, you could just do parentheses 1 divided by 2 times 2. Yeah.
Would you, on a test, would you accept the answer if it was x equals -6 plus or minus 2i?
Say again? X equals -6 plus or minus, just putting x over there?
Yeah.
Oh, absolutely, yeah.
Is it possible to have one imaginary answer?
No, because anytime you get imaginary, it's because you square rooted a negative, and anytime you square root is a plus or minus situation. So no. Yeah. Why do I multiply by 2? Because at this point, I had 1/2 times x plus 6 squared, what I had equals -2. And what did I want to get rid of? The 1/2. Well, what happens when you multiply 1/2 times 2? You tell me what happens. What's 1/2 times 2? Put the 2 over 1, right? Multiply across.
1.
You get 2 over 2, which is 1. So this becomes 1 times x plus 6 squared, which is just x plus 6 squared. So it goes away. Okay?
But aren't you supposed to be dividing the 1/2?
If you divide by, so watch what happens. Here we go. Ready? X plus 6 squared divided by 1/2. Anybody remember how to divide by a fraction?
By multiplying it by its opposite?
What's the opposite of 1/2?
2 over 1.
Which is 2, which is multiplying by 2. Yeah. So this would become 1/2 times x plus 6 squared times 2 over 1, which is 2. Yeah, it's the same thing.
But then it would become, then the equal would be -4, wouldn't it?
Yeah, that's what we have over there. That's what we had, yeah.
Okay.
Yep. These are all the same thing, just doing them different ways. All right, moving along. Another different one. Okay, this one, what's it missing? C. Two options here. I can add one. I can say plus 0, and I can do a magic x. Or I can recognize, there's a quicker way. 0 equals x squared minus 15x. What does this have? What do both of them have? X. If everything has something, if you can divide everything by it, it's a GCF. This has a GCF. It's x. 0 equals x minus 15. Right? You just divide them both by x. Right?
Wouldn't that x become a 1 on the outside?
Nope. You got two things that are multiplying to give you 0. So either this is 0 or this is 0. This is done. And then this would be plus 15, x equals 15. And those are my two solutions.
That just broke my brain.
Remember the rule, a times b equals 0, meaning two things that multiply to give you 0. One 0 or both are 0 or the other one's 0. Like something's got to be 0 here or both of them got to be 0. Well, what do I have? I have something times something equals 0. Either that's 0, or they're both 0. So I just set them both equal to 0. Okay? Yeah.
I got the same answer, but I did.
You did plus 0 at the end?
No, I did x squared minus 15x over x, and 0 over x, so it would be 0, like both ways.
Okay. We got the same answer. Yeah. No, 0 can be a real root. It's a good question. That means, well, that's not going to work. That means that this has x-intercepts at 0 and 15. 0 is just one of the roots. Yeah. So it would be like this. Okay? All right. Let's see. I'm going to show you how to set this one up, and then we got to move along here. Minus 1 gives you negative 9x squared minus 900. Oh, sorry, equals minus 900. Divide by negative 9, divide by negative 9. X squared, I know I'm going fast, equals 100. Square root both sides, you get plus or minus 10. That one was just weird because it wasn't equal to 0 to start. All right. Oh my God. Yeah.
The standard form. Do we have to make x alone first, so we need to divide by 2? Or not?
Yeah, so this has a GCF. 0 equals negative 2 times x squared minus 11x plus 30. So if you did rainbow or reverse box here, you were doing too much work. It had a GCF, pull that out, and then magic x this. That magic x would be 30 over minus 11, which is minus 6 and minus 5, and then you go from there.
Answer number 8 again.
Square root, x equals plus or minus 10. Ready?
Let's go to the lesson.
Yeah, I think we got to go to the lesson. Okay, number 10 is like number 2. So if you didn't do number 10, just go back to number 2. Number 11, you just needed to move over the 5 and square root. And then account for your imaginary numbers. And then I think we got to go to the lesson. Okay.